Hi students, yesterday we have revised all the concepts of limit, all the formulae of limit. Now we are going to study continuity. In this continuity, continuous and discontinuous functions, it contains the first point, that continuity of a function at a point. Now when can we say that one function y is equal to f of x or any function is continuous at any point x is equal to a? First of all, understand the definition. A function f of x is continuous at x is equal to a if the value of f of x at x is equal to a exists, the limit of function f of x as x tends to a exists, and limit of f of x as x tends to a is nothing but equal to f of a. If all these 3 points are satisfied by any function at that point, then we can say that that function is continuous at that point. All the 3 conditions. First condition, the value of f of x at x is equal to a exists, means f of a exists. Second, its limit should be exist, and third, the limit of the function and the value of function must be equal. Now let's understand the concept. When can we say that limit of f of x as x tends to a exists? We know that if the given function can be limit of the given function can find out directly and will get some value, then we say that this limit exists. Second one, if function changes for x is less than a and x is greater than a. We know that sometimes function is given like this, f of x is equal to some function x plus 3 for x is less than 3 and is equal to 2x for x is greater than 3. Now here what can we observe? We can observe that the function changes for the values less than 3 and greater than 3. Means if you try to find this limit at x tends to 3 minus and 3 plus, then limit of function at x tends to 3 minus will get 3 plus 3 6, and x tends to 3 plus, for that we'll get 2 into 3, that is 6. Means here we can observe that limit of f of x as x tends to 3 minus is equal to limit of f of x as x tends to 3 plus. Hence we can say that if left hand side limit and right hand side limit are equal, then limit of f of x as x tends to a exists. Means here we can easily say that limit of the function f of x as x tends to 3 exists. And if these values, in some conditions, if these values are not equal, instead of this, suppose this is 3x, then we have to write this left hand side limit and right hand side limit are not equal, because we get the right hand side limit as 3. Then remember these 3 concepts. Now observe these figures, figure 1, figure 2 and figure 3. In these 3 figures, here we can observe that in this function, the value of function at x is equal to a does not exist. Here in this figure, f of a does not exist. Look at this, there is a hole in the figure. It means the value of the function does not exist. If you observe this second figure, what can you observe? Now look at this. Here the left hand side limit and right hand side limit are not equal. Limit of f of x as x tends to a minus is not equal to limit of f of x as x tends to a plus. Because the left hand side of a, it has a graph and it is a break in the graph at the same point x is equal to a. It is starting from another point. Another place pasun to start with. It means the limit of f of x as x tends to a minus is not equal to limit of f of x as x tends to a plus. Means again we have this limit of f of x as x tends to a does not exist. And in third figure, we can say that the left hand side limit and right hand side limit are starting at the same point. Means here we get limit of f of x as x tends to a minus is equal to limit of f of x as x tends to a plus. Because both LHL and RHL are at the same place, means they are equal, means here limit of f of x as x tends to a exists, but the value of function f of x, this is f of a, which is different from the line. It is not in that line. It means we can say that f of a also exists and limit of f of x as x tends to a is not equal to f of a. Means in these three figures we can say that the function is not continuous because of the reasons. In first function, the first condition is not satisfied, means value of f of x as x tends to a does not exist, means we have no idea about the value of function at x is equal to a. In second function, as LHL and RHL are not equal, therefore limit of f of x as x tends to a does not exist. And in third function, the limit exists as well as the value exists, but they are not equal. Hence all these three graphs says that these functions are not continuous at x is equal to a. If this function is having graph like this, look at this, y is equal to f of x, this function has continuous graph from left side of a as well as from the right side of a, and both graphs are joined by the value of function at x is equal to a. This is said to be f of a. Means here in this graph we can say that graph of the function is continuous because the value of function f of x as x tends, value of the function at x is equal to a and limits of the function at x is equal to a are approaching to each other, means they are equal to each other. Hence such function is said to be continuous function. This function satisfies all the three conditions which we have studied in the definition, that limit of f of x as x tends to a exists because both limits from left and right are equal and the value of function is also the same, hence that function is said to be continuous. Now continuity of the function from the right and continuity of the function from the left. How can we say? The function f of x said to be continuous from right at x is equal to a if the limit of function f of x as x tends to a plus is equal to f of a, means left hand side limit, right hand side limit is equal to the function value of the function. Hence we can say that the function is continuous from the right side of a, and here the continuity from the left is the function f of x is said to be continuous from the left at x is equal to a if limit of f of x as x tends to a minus is equal to f of a, means left hand side of limit is equal to the value of the function, then we can say that the function is continuous from the left. Now look at these two examples. In first example, function f of x is equal to x plus 3 for x is less than 2 and is 2x plus 3 for x is greater than or equal to 2, means exactly from 2 function changes 2 and onwards, that is 2x plus 3, means there are three cases: x is less than 2, x is equal to 2 and x is greater than 2. And here we can observe for x is equal to 2 and for x is greater than 2 function is same. Now find limit of f of x as x tends to 2 minus, means left hand side limit. Here limit of x plus 3, because for 2 minus means x is less than 2 and for that function is x plus 3. Therefore its limit is, if we substitute this value, it is 2 plus 3, that is 5. For f of 2 means the value of function at x is equal to 2. means substitute for x is equal to 2, function is 2x plus 3 now. Means here we have to substitute value of 2 in this function. 2 into 2 plus 3, that is 4 plus 3 is 7, and limit of f of x as x tends to 2 plus right hand side limit, the function is same 2x plus 3 for x is greater than 2, hence limit of 2 into 2 plus 3 as x tends to 2 is equal to 7. Now observe these three things. Here the value of the function and right hand side limit are having same value, it means they are equal, and if they are equal we can say that the function is continuous from right side of x is equal to a. Now look at this example. In this example we have written this function as f of x is equal to x square plus 1 for x is less than or equal to 3, means exactly up to 3 function is same. X is equal to 3 is appearing here. It means limit of f of x as x tends to 3 minus, means x is less than 3. For x tends to 3 minus, function is x square plus 1. While finding its limit, it is 3 square is 9, 9 plus 1 is 10. And value of the function means for x is equal to 3, the function is same x square plus 1. Hence x value is also 10. But function changes for x is greater than 3, that is 2x plus 3. If you find its limit, 3 into 2 6, 6 plus 3 is 9. Hence we can say that only these two values are equal, 10, 10. Hence the limit of f of x as x tends to 3 minus is equal to f of 3. It means that function is continuous from the left side of x is equal to a. Now we'll see some examples of continuity. Look at the functions first. Observe them carefully. In the first example, function f of x is given x square minus 5x plus 4 upon x minus 1 for x is not equal to 1, is equal to minus 3 for x is equal to 1. In this function, x is not equal to 1, it means x is either less than 1 or greater than 1. Means for all the values x is less than 1 and greater than 1, function is same. It will never change. Because this is a rational function and rational function does not changes. Now in second function we can observe that the function f of x is given 2x plus 3 for x is less than 2, the value 7 at x is equal to 2, and x cube minus 1 at x is greater than 2. Means x is less than 2 and x is greater than 2, function is different. Here in this example, for x is less than 1 and function x is greater than 1, function is same. And in third example, say f of x is equal to mod x upon x, x is not equal to 0 and is equal to 1 for x is equal to 0. Now we know that the definition of modulus function, mod x is always written as x for all the values of x greater than or equal to 0 and is minus x for x is less than 0. Means itself this function mod x changes for values of x greater than 0 and less than 0. Here as we write x is not equal to 0, it means it contains both the things, x is less than 0 as well as x is greater than 0. It means the value of mod x is going to change. Observe these three functions. Now we'll see the continuity of these functions. Now remember again the definition of continuity. Definition of continuity says that the limit of function must be exist, value of function must be exist, and they must be equal. Then we can say that the function is continuous at that point. Now here in this function we are going to discuss the continuity at x is equal to 1. It means here we are going to find the limit of the function first. As function is the same for x is less than 1 and greater than 1, find its limit. Directly limit of f of x as x tends to 1 is equal to. In such functions there is no need to find LHL and RHL separately. Means left hand side limit and right hand side limit. दोन्ही काढणं गरजेचं नाहीये. Limit of f of x as x tends to 1 is equal to limit of x square minus 5x plus 4 divided by x minus 1 as x tends to 1. Now this is a quadratic function. Find its factors. 4 has two factors. 4 ones are 4, which addition is minus 5 is equal to limit of, it has two factors, x minus 1 into x minus 4 divided by x minus 1 as x tends to 1. Now x tends to 1 means x is not equal to 1. As x tends to 1, we can say that x is not equal to 1, means we can cancel these factors. That is equal to limit of x minus 4 as x tends to 1. Substitute these values, it is 1 minus 4, that is minus 3, and therefore we can say that limit of f of x as x tends to 1 is equal to minus 3. Now here minus 3 for x is equal to 1 means f of 1 is given directly minus 3. Therefore limit of f of x as x tends to 1 is equal to f of 1. Therefore f of x is continuous at x is equal to 1. This is the first example. Now look at for second example. F of x is equal to, the function is different for x is less than 2 and greater than 2. In such functions, it is clear that we have to find left hand side limit and right hand side limit separately. Means here we will find first LHL. LHL means limit of f of x as x tends to 2 minus. That is equal to limit of, now for 2 minus means x is less than 2 and function is 2x plus 3 as x tends to 2 minus. Find its value, that is 2 into 2, 4 plus 3, that is nothing but 7. Then we will find RHL. RHL is limit of f of x as x tends to 2 plus, that is equal to limit of, now 2x plus 3 is for x is less than 2, 2 plus means x is greater than 2, now function is x cube minus 1 as x tends to 2 plus. Now substitute this value, this is 2 cube means 8 minus 1, that is equal to 7, and the function's value is given 7 means f of 2 is equal to 7. Observe that left hand side limit is 7, right hand side limit is 7 and value of the function is 7, means we can say that limit of f of x as x tends to 2 minus is equal to limit of f of x as x tends to 2 plus is equal to f of 2. Therefore we can say that f of x is continuous at x is equal to 2. Now look at this function. Here mod function is in the function, means first of all we have to remember that we know that mod x is equal to mod x is equal to x for x is greater than or equal to 0, and it is minus x for x is less than 0. Means when x is negative, to make it positive it is minus x. Now here x is not equal to 0 means x is less than 0 or greater than 0, but function changes for both the terms. Therefore we are going to find LHL and RHL separately. Now LHL, limit of f of x as x tends to 0 minus, function is given mod x upon x for x tends to 0 minus. For 0 minus, this mod x becomes minus x, means limit of minus x upon x as x tends to 0 minus. As x is not equal to 0, x get cancelled, is nothing but equal to minus 1. Limit of constant is always constant. Now RHL is equal to limit of f of x as x tends to 0 plus, is equal to limit of mod x upon x as x tends to 0 plus. That is equal to limit of mod x is nothing but x for x is greater than 0. Function is always x divided by x as x tends to 0 plus. Now x get cancelled, hence it is 1. And f of 0 is given 1. But observe that LHL and RHL both are not equal. LHL is minus 1, RHL is plus 1, means LHL is not equal to limit of f of x as x tends to 0 minus is not equal to limit of f of x as x tends to 0 plus. Therefore, we can say that f of x is discontinuous at x is equal to 0. Thank you, students. Practice the examples on this concept from the textbook. We'll see another examples in next lecture.